Hello friends, so in the previous video we started off with permutation and we understood what is the concept of permutation, right? So we have discussed two types. So what do you mean by permutation? In simple language it is nothing but arrangement. So an arrangement is called as a permutation, okay? So other arrangement is another permutation. So we have seen permutation of n distinct items in two different cases, okay? There are three possible cases. Let's suppose you have n distinct items. This is very important, n distinct items. What are the three cases? You can take all n at a time and you can arrange. So how many arrangements possible? So the first possible case is taken all at a time. Taken all at a time. Now sometimes you may not take all at a time. Now one example for that is, let's suppose you have A, B, C, three letters. And how many three-letter words you can make by using the letters A, B, C? If that is a question, you are taking all at a time. That means you have to fill three places with three letters. Now instead of that, sometimes you will take some at a time. You won't take all. You will take some at a time. For example, same three letters is given, but you will be asked to find how many two-letter words you can make. In that case, you need to fill two places. So this is the arrangement of n distinct items taking some at a time, right? So first case, three distinct items, three at a time. That means n distinct item, n at a time. Second, three distinct item, two at a time. That means n distinct item, some at a time. Okay, so n distinct items taken all at a time arrangement, n distinct item taken some at a time arrangement is what we have discussed. Okay, so what was that? N distinct items taken all at a time is n factorial. N distinct items taken r at a time where n is greater than r, right? So that is npr, and npr we know that is n factorial divided by n minus r factorial. So this is what we have discussed. Now you may ask me if I am not taking anything, that is np0. If you are not taking anything, that is np0, that is 1. You can have one way in which you can't select anything. You are not selecting anything, that is also one possibility. So one way. Okay, so we have taken care of all the possibility. Either you are selecting all, or you are selecting some, or you are not selecting anything. So selecting all, n factorial, selecting and arranging some, then it is npr, not selecting anything. So there is no arrangement, only one way. Okay, so that is what we have done. So this don't discuss now, that's not required for us. Just think of these two possibilities, that is n factorial and then npr. N distinct items taken n at a time, n distinct items taken r at a time. Let me discuss one example now. Okay, now let's take this case cinema. Okay, so let's take this case cinema. So letters of the word cinema, how many letters are there? 6 letters are there. And what is the speciality? All the 6 letters are distinct letters. Okay, so you have 6 letters, 6 distinct letters are given to you. Now let me give you different cases. So simply if I ask you how many 6-letter word, how many 6-letter words I can make with the letters of the word cinema? This is a simple question. So I need to make 6-letter word. So I need to fill 6 places. Very simple, right? How many ways? You have 6 letters. You need to fill 6 places. You know n distinct items, n places, n factorial ways. So here you have 6 distinct items in 6 places. You can do that in n factorial, which is 6 factorial ways. Now how this is getting 6? See, the conceptually it is like this. See, this is the first place. Okay, so the first place can be filled with any of the 6 letters. So you have 6 choices, right? So the first place can be filled in 6 ways. Next place, you are now consuming 1 letter and repetition is not allowed. You cannot repeat the same letter. So you are left out with 5 letters. So in how many ways you can fill next place? That you can fill in 5 ways. Now you already consumed the 2 letters. How many is left out? You are left out with 4. So this is 4. Then you are left out with 3. Then you are left out with 2. Finally you will be left out with 1. So you have only 1 way. And you need to fill all these places. It is not that any one place. No. So you need to fill all. So you need to multiply. And that's how you are getting the 6 factorial. So I hope this is clear for all of you. No need to have any doubt in this case, right? So this is crystal clear. Now let me go for the second case where I'll give you some restriction. So I am taking this word cinema itself and I want you to find how many 6-letter word you can make. Again 6-letter word, but this time I am going to impose some restriction. In the previous case there was no restriction. I can ask you how many 6-letter words you can make, that's fine, 6 factorial. But here I'm going to tell you that this should start with n. This should start with n. Okay, so this is your second type. We are going to discuss the different types of questions that you can get. So it should start with n What does that mean? So with respect to the first position, you have no choice. And how many ways you can do this? You have only one n, right? You have only one n. So you have only one way. You have no other way in which you can fill the first place. So the first place is filled in one way. And with that, keep in mind that you consumed one letter. And how many letters are left out now? 5 letters are left out. How many places are there? 5 places are there. 5 letters, 5 places, n things, n places. How many ways you can arrange? 5 factorial or n factorial, right? So this is going to be 5 factorial ways. Now how this 5 factorial? Because this is 5, this is 4, this is 3, this is 2 and this is 1. So that's how you are able to fill this in 5 factorial ways. So the point is, letters, there are 6 factorial total words are possible with the letters of the word cinema. Out of that, if I ask you number of words which are starting with n, that is 5 factorial. So obviously number of words starting with C will also be 5 factorial, because instead of n it will come C. I also 5 factorial, E also 5 factorial, starting with M also 5 factorial, starting with A also 5 factorial. So basically, starting with any of these words, it is 5 factorial. And these are the only ways in which you can start also. So this 6 factorial is effectively 5 factorial plus 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 5 factorial. Why? Because this 5 factorial is the words which is starting with C. This is nothing but starting with I. Then this is nothing but N. This is nothing but E. This is nothing but M. This is nothing but A. And these are the possible ways in which you can start the word, right? So with C there are 5 factorial words. With I you have 5 factorial. With N, with E, with M and A you have 5 factorial. If you add everything, you'll be getting 6 factorial. That is nothing but the total number of words that you can make with 6 letters. I hope this is clear for all of you. Now the third case, case 3. Again we have the letters of the word cinema, but this time what I'm going to tell you is how many words you can make with the letters of the word cinema such that it should start with N and end with M. Start with N and end with M. So what does that mean? The first place and the last place is fixed as N and M. Now how many places are left out? 1, 2, 3, 4. So this N is consumed here and this M is consumed here. And since one N and one M is there, this can be done only in one way. You can't put any other letter and you don't have any choice in case of N also. So only one way you can do that. This M also can be done in one way. Okay, so this starting with N and ending with M is fixed, that is only in one way. But rest of the letters, there are 4 places and you have 4 letters, right? C, I, E, M. So C, I, E, M can be arranged in how many ways? So each N and M, there are 4 factorial different arrangements. Why 4 factorial? Because 4 letters and 4 places. N distinct items in N places. So the permutation of N distinct items taken all at a time is N factorial. Here N distinct items, N places, or 4 distinct items, 4 places, 4 factorial is your answer. So if the condition is given that it should start with N and end with M, your answer is 4 factorial. Okay, now let me modify this condition. Instead of saying that it is going to start with N and end with M, I may tell you that I need to get the possible number of words with the letters of the word cinema such that, okay, the extremes should be N or M, or extremes should be N and M, or N and M should occupy the extreme position. Okay, so what is the fourth case? N and M occupy extreme position. N and M should occupy extreme position. So how many ways you can do this? Now, what do you mean by N and M should occupy extreme position? I can put it in this way. It can be N or M. This also N or M. What is the difference from the previous case? In the previous case, I have specifically told you N in the beginning and M in the end. That is only one way. But here, N or M can come in the first place. N or M can come in the second place also. Okay, so within N and M you have 2 ways in which you can arrange that. Now, corresponding to each such arrangement, so how can you do this? It can be N in the beginning and M in the end, or M in the beginning and N in the end. And then if the first is the case, you have 4 letters left out which can be arranged in 4 factorial ways. In the second case also you have 4 letters left out which can be arranged in 4 factorial ways. And any one of this will come. Okay, so both cannot come, because if N is used here and M is used here, then M can't come here, right? So any one of this will come. So either this or this. So what is your answer? 4 factorial plus 4 factorial, which is nothing but 2 times 4 factorial, which is equal to 48. Okay, so there are 48 words in which n and m can come in the extreme position. Okay, so it can be this n coming in the first and m coming in the end, or m coming in the first and n coming in the end. So here this was 4 factorial because it is crystal clear that n is the beginning and m is the end. So now this is one way. Or what is the alternate way in which you can do this is like this. See, the first and last one condition, and then fours, there are no condition, right? So first and last, how many ways you can fill this? You have 2 places, you have 2 letters. So n places and n letters. So 2 distinct items, n and m, and 2 places. So how many ways you can do that? You can do that in 2 factorial ways. What was that? Mn and nm. This is what I mean by this 2 factorial ways. And because you need to fill the other places also. Other places can be filled in how many ways? 4 places and 4 letters. 4 factorial ways. This will also give you the same answer, 48. The point which I need to convey you is that here I am using the AND logic, which is going to give you the answer faster. But here I am using the OR logic, which involves more conceptual clarity, and you need to do in this way. And for exam, this is not required. You will directly and straight away think in this way that 2 places can be filled in 2 factorial ways, 4 places in 4 factorial ways, depends on the condition, and then we need to do both, so you just multiply, so you get this as answer. That's how you do in the exam. Okay, now let's move on. I'll give you next condition. Again the same word, okay, so I am giving you the same word again, cinema. Now the condition here is how many words you can make with the letters of the word cinema such that, now write the condition, such that n and m always comes together. N and m always comes together. Now what you need to do? So what they are saying is n and m should come together. Okay, now what you need to do is you need to keep n and m together like this. Then you have 1, 2, 3, 4 ways in which you can arrange. So n and m should be together, and other 4 letters you can arrange in normal way, right? But is there any information that's saying n and m should come in the beginning? No. That means this n and m can come here, it can come here, and it can come here. So we need to see all those possibilities. For that, what we will do, we have to take this together as one entity or one letter, and wherever it go, it will go together. N and m will go together. Okay, so it can be placed here, it can be placed here, it can be placed here. So we will consider this as one place or one letter, one entity. Then this is second letter, third letter, fourth letter, fifth letter. Now the sixth letter is reduced to 5 because n and m I am keeping together. Okay, so how many ways you can do that? You can do that in 5 factorial ways. So, but this 5 factorial is talking about n and m like this and then others. Okay, so but this n and m can come here, this n and m can come here, this n and m can come here, all those possibilities are taken care. But this n and m can again have 2 possibility. It is nm and mn. So total 5 factorial ways in which you can arrange the positions, and within that n and m can interchange among themselves, so 2 factorial ways. So this is the number of ways in which n and m will always comes together. I hope you understood. So what we did is we keep n and m as one entity. So wherever they move together. So you have 5 factorial ways in which they can move. But within themselves, again, for each those corresponding arrangements, you have further 2 arrangements because nm and mn is possible. So 2 factorial. So that's what your answer. Now, instead of n and m, if I tell you n, m, e together, how will it differ? So you need to keep these 3 together. Then you have 3. So you need to consider this as 1 place, 2nd place, 3rd place, 4th place. So how many ways it can move among themselves? So 4 factorial ways. 4 place, because we need to consider this as 1 place. Then NME, within that you can have NME, you can have NEM, you can have MNE, you can have MEN, such kind of 3 factorial arrangements. So 3 factorials. I hope this is clear for all of you, right? So see, let me give you one way of understanding this. You have NME, alright? Then others can be placed in AIC, like this, okay? So this is one way you got it. Now for this itself, now you take this NME, that can be interchanged. So NME, instead you will write NEM, AIC. That's a different word. But again NEM are together. Similarly, ENM, AIC. It's again a different word, but the condition is satisfied. Similarly, EMN, AIC. Condition satisfied, they are together. Similarly, MEN and MNE, the condition is satisfied, they are together. That's what I mean by this 4 factorial into 3 factorial. I hope this is clear for you. Okay? Now, one more case. How many words you can make with the letters of the word cinema? Okay, such that, now the condition, listen carefully, N and M are never together. They will never sit together. Okay, so such that N and M never together. So just now we have learned the number of ways in which N and M can be together. Okay, now the question is not that how many ways in which N and M cannot be together. Now, do we know the total possible ways in which you can get different words? Yes, we have 6 letters. We have 6 places, so we know the total number of words you can make is 6 factorial, no doubt in that. That is the first concept that we have learned. The total words possible are 6 factorial. Just now we have learned how many ways N and M can be together. What we do, N and M we need to consider as 1, then other 4 places. So this can be in 5 factorial into 2 factorial ways. So N and M are together in 5 factorial and 2 factorial ways. Total words are possible is 6 factorial. So N and M are never together how many ways? Total minus whenever they are together. So there are only 2 possibilities. Either they are together or they are not together. There is no other possibility. Once we know the total and once we know all are together possibilities, we can easily get the possibilities where they are not together, right? So answer is 6 factorial minus 5 factorial into 2 factorial. What is that? 6 factorial is 720 minus 5 factorial is 120 into 2, that is 240, which is equal to 480. So M and N are never together as in 480 ways. And these are the 2 possibilities. Either 240 ways they are together or 480 ways they are not together, and that many words are there. That is 720 words. Okay. One more question which looks easy. Let me give you that question, but it is actually confusing. Many students have asked me about this question many times. They have a confusion. So that's why I'm clearing this. Also, already this concept is discussed. Okay. So again, cinema, how many words are there which start with CIN? How many words you can make with the letters of the word cinema? Obviously that is the first part, but it starts with CIN. How many words are there? C. Thing is, CIN is fixed. How many ways it can be done? You have only one C, one I, one N. So this can be done only in one way. This is fixed. This can be done only in one way. No need to have any confusion with this part. This is done. This is only in one way. Now repetition is allowed. You have 3 places to fill. You have 3 choices. What are they? M is there, E is there, A is there. These are the 3 choices, right? Now, see here, it is crystal clear that it is starting with CIN. It is not that CIN is always together. CIN is always together and starting with CIN is a different case. CIN is together means this can come here also. Within CIN, it can, even if it is here, it can be INC also. Then also CIN are together. But it is specifically told that it is in the beginning, that is starting with CIN. That means first thing, you cannot alter the order and you need to fix it here only in this point. It can't come here. It can't come here. So you may think that you need to consider it as one entity. No, there is no such things. This is separate. Only in one way. Now this 3 can be arranged in 3 factorial ways. That many number of words are going to start with CIN. So what are those words? CIN I fix it. It is MEA or MAE or EAM or EMA or AEM or AME. So these are the 6 words which is going to start with CIN. But if the question was CIN is always together, then it is different, right? CIN is together means you will consider CIN, then 3 places. Then the CIN can be together even if it is in the end also. Then you will consider this as one entity, this is second, this is third, and this is fourth. So 4 factorial ways. Then within CIN, there are possibility of INC, NIC, etc. So that can be done in 3 factorial ways. But that possibility is not available here. So I hope this is clear for all of you, right? So starting with CIN is completely different to CIN is always together. Okay, so that is what we need to discuss. Now the next very important concept that I need to discuss is, see, I again want to get all the words which are possible to make with the letters of the word cinema. The first part remain the same. I am again using this 6 letters itself, cinema. Now such that the condition is vowels should occupy the odd places. Vowels at odd places. Okay, so vowels should occupy odd places. So what are the vowels here? I, E, A. So you can see vowels are I, E, A, and you can see here consonants as C, N and M. Okay, now this question can be asked in this way: vowels occupy odd place or consonant occupy even place. Anyway, this can be asked. Or now again, if I need to make a new question, vowels occupy at even place or consonant at odd place. So these are the ways in which you can make questions. But now what do you mean by vowels occupy odd position? It can be like this: 1, 2, 3, 4, 5, 6 places is what we need to fill, because we need 6 letter words. Odd position means the first position and the third position and the 5th position. So these positions should be vowels I, E, A. Now they are not specifically told that first position with I, third with E and fifth with A. That means this itself can be interchanged. So we have 3 places, 3 odd places and 3 letters. How many ways you can do that? 3 factorial ways you can do that. How? It can be I, E, A. It can be I, A, E. Still you can make a 6-letter word, vowels occupying odd position. It can be E, A, I. You can make a 6-letter word. E, I, A. You can make a 6-letter word where vowels occupying the odd position. Now finally A, E, I and A, I, E. So these are the 6 possible ways in which you can keep vowels at the odd position. 1, 2, 3, 4, 5, 6. So there are 6 possible ways in which you can keep vowels at the odd position. Now corresponding to each such arrangement, you take this case, first case, corresponding to each such arrangement, you have further ways in which you can keep the consonants. Okay, see, you have 3 places now left out. So you have 3 places left out. In those 3 places you can fill 3 letters, right? So that you can do in 3 factorial ways. That's what we have learned, right? It can be C, N, M, it can be N, M, C or whatever it is. So corresponding to each such arrangements you can see here, you have 6 further possibilities or 3 factorial further ways. So this second one again 3 factorial. Third one again in 3 factorial, fourth again in 3 factorial, this again in 3 factorial, this again in 3 factorial. So the question is how many words you can make such that vowels occupy odd position. So I, E, A is the vowels, so it can be placed in any of this way. So the answer is the first one or the second one or the third one or the fourth one or the fifth one or the sixth one. So 3 factorial plus 3 factorial up to 6 times. 6 times 3 factorial is your answer, or 6 into 3 factorial, which is nothing but 6 into 6, which is equal to 36. So there are 36 words where vowels occupy the odd position. I hope this is clear. Now this can be easily done by using the concept of AND. See, here we are using OR logic, that's why we are adding everything. By using concept of AND, how will you do this? See, you have 6 letters, 6 places, but what is the condition? First place, third place, fifth place is fixed. That is for vowels. So how many vowels? 3 vowels. 3 distinct vowels, 3 places. How many ways you can do that? You can do this in 3 factorial ways. Now how many letters left out? 3 letters left out. How many places left out? 3 places left out. So 3 distinct items, 3 places can be done again in 3 factorial ways. And since we need to fill all the places, you need to multiply. So 3 factorial into 3 factorial, which again will give you 36. So either this method, this is a shortcut method, and this is the best approach. Okay, so what we need to do is, what we have done, the question is vowels occupy at odd places. So these are the vowels. This can come in 6 ways. So for each 6 ways, you have further 3 factorial arrangements where you can place consonants. So consonants can be placed in 3 factorial ways. So by using OR logic, you need to add everything, or by using AND logic, we have 6 places. 3 places need to be filled with vowels, so 3 factorial. Then 3 places need to be filled with consonants, again 3 factorial. Since we need to do both, we need to multiply, and we got the answer as 36. I hope this is clear for all of you. There is no need to have any doubt here. So very important concept that we have discussed today. Revise it nicely. We will come back.